I was looking through my CV a few months ago, and despite the entries in Hall of Fames and VDPs and challenges, there was one thing I didn't have, which was a bug bounty. Now, whether you like bug bounties or think they're the overhyped security equivalent of NFTs, a lot can be said when somebody is able to demonstrate they can touch a real application for a real company and find bugs that are worth being paid for, all whilst other researchers are testing the same application. So on that weekend, I decided I would rectify this and try to find a bug worth being paid for so I could check this one off the list. So I'll be explaining exactly the bug I was able to find, how I found it, and how I was able to turn a very uninteresting, very plain XSS into an XSS capable of stealing people's purchases and even stealing their credit card information so that I could buy whatever I wanted on their money. Now obviously, since it was a bug for a real private program, I can't disclose specifics about the application, so instead I decided to recreate the application, the core functionality, and show you exactly how it works, but kind of written in my own application. So the application itself is super simple, right? It's literally just a kind of e-commerce site where you log in on your account, you go and you buy a product, and now you own that product. Only on the real application, you were not buying any kind of product, you were buying license keys, right? So you could just copy your license key at the end and paste that into your program and you unlock the pro version. So here obviously is very similar to that, it's just that obviously instead of buying license keys, we're buying goats. So at first I initially spent a few hours poking around the application and just messing around with random parameters and seeing how it reacted, and I started testing the OAuth login flow. And during that, something I did sent me to a web page which would display an error message. So basically, the web page that it brought me to just looked something like this. It just had a URL parameter where the message was being output into the page, and I'm sure many people already know where this is going. This is vulnerable to reflected XSS. So if we put in a payload in here, like script tags, we do alert 1, we can see that it actually does get embedded directly in the page, and we can run our own JavaScript. Now, at this point, I can't help but be a bit disappointed because sure, I made a bit of extra money because I managed to find a bug, and sure, I managed to achieve my goal of getting paid for finding a bug, but like, this is not exactly groundbreaking work to find reflected XSS in a URL parameter. So at this point, I reported the bug as a medium severity, which you probably shouldn't do if you think you can escalate, because if the company moves too fast, then you could basically patch yourself out of a high or a critical bug. The problem with escalating this higher is that the XSS, it appears on a very kind of boring page, right? There was really not much I could do with it. There wasn't even a whole lot of functionality. It was a really, really simple portal, essentially. Just log in, buy your products, that's it, right? You get your code. So at this point, I was trying to think of ways that we could have some kind of effect on the user, but the simplicity of the application, I just couldn't seem to find anything. So this got me thinking about potentially using cookies, right? So obviously back in the day, an attacker using XSS could just steal your cookies straight out of the browser using JavaScript's document.cookie, and that was it. GG for the victim. But the thing is, those days have long gone, right? We can't just do that anymore. We can't just grab cookies out with document.cookie because all of the session cookies are HTTP only, right? So the juicy information only gets sent over HTTP. So if we go to our request headers, we can see that this JWT token is exactly what we need for our session, but it's only being sent via HTTP. So what about writing cookies, right? Well, we know we definitely can't edit the HTTP only cookies, right? That's the whole point of HTTP only. Everything has to happen over HTTP. But what we can do is insert a new cookie, right? So if we just do test equals test and end that, just the most simple cookie ever, well, now when we go document.cookie, we can see our cookie is here. But, well, this is kind of useless because adding a new cookie doesn't actually really do anything for us. I mean, unless the server is actually specifically written to handle that cookie in some way, it's just pointless, right? So we really want to be able to touch a cookie that we know the server definitely will be handling. So at this point, my thought goes straight back to JWT, the session token. What if we could do something there? So what if we created a new cookie, but it has the same name as an existing cookie? So for example, the JWT session token, what if we added a new JWT session token to our cookies? Which one will the server read? So I can tell you the answer to that, and that is that it will always read the first occurrence. And the first occurrence is essentially decided by this state management RFC. So as we can see in the RFC, cookies with earlier creation times are listed before cookies with their later creation times. So the original cookie that the user got when they logged in will always take precedence over any new cookie that we give them. However, the other part of this RFC is very interesting, and that is that cookies with longer paths are listed before cookies with shorter paths. So what the RFC is referring to is this path attribute here. So this is just an example of what a cookie looks like. And we can see that the path is just scoped to /, meaning everything in the domain, right? So because obviously this is a session token, it needs to apply to the entire site, right? Once you've logged in. So according to the RFC, if we had a more specific path, like example, then anytime we went to /example, our cookie should take precedence over the regular one that just applies to everything, because we're saying, hey, I have a very specific JWT token that I only want to apply to this particular path. So now the idea is that we use the XSS we found to set a session token specifically set to a path that we want to apply our session token to. And what that would allow us to do is take our attacker account's token, apply that to a victim account, and wait for them to do a sensitive request, like to buy a goat, and then it would essentially apply that entire action, but apply it to our account. So what we're going to do is test and see if my idea works, and see if we can take the attacker cookie and use the XSS that we found to apply that to a victim account, and then use that to steal those requests from the victim and apply them to the attacker account. So let's start off by just showing what a normal purchase would look like. So if we just purchase this goat, we can see we have now owned the goat, and if we check on the request, we can see that we did it to the /buyGoat endpoint, and we can see that the JWT token was sent, as it would be for every request. So what we can do is take the JWT token out of here and copy that here, and we'll just do it down here because I just need somewhere to write some text. So we obviously need script tags because we are going to be trying to get this to execute inside of our XSS that we found. And then we're going to do document.cookie equals, and then we will set our JWT token. But as we already know, we need to specify a more specific path to make sure that the existing JWT token gets kicked out the way whenever somebody goes to this particular path, which I believe was /buyGoat. So if we take this payload and we go back to our XSS and we replace that in here, now if we copy the entire URL, we have a URL that we just need to send to a victim. Anyone clicks on this link and they should have this JWT token armed and ready to go whenever somebody goes to the /buyGoat endpoint. So let's try it out. We have a victim account logged in here who owns no goats, and let's say somebody clicks on this link, visits it in some way, and they have no idea what happened. It's just a big white screen, but obviously anyone can edit that. We have full control since it's XSS. We could just make it look like the real website or just redirect them to the main page or something. But we can see that what actually ran in the background was that we set that document.cookie, and now the user will be able to use this website just like normal, right? And they won't change. They will always be logged in as the victim, because that JWT token will only get fired when you are sending that to that particular path, right? So let's say we want to buy a goat. Let's buy Cool Harry. So once we fill out our details and we go to click purchase, we now bought Cool Harry, but we can see that the goat still exists here and hasn't been purchased. But if we look at our request, we can see that in fact 2 JWT tokens got sent on our request instead of just the normal one. And one of those, obviously the first one, takes precedence over the other one, as I said. So this JWT token right here will not have been taken into consideration when buying Cool Harry. And so we are left with no goat purchased here. And as we can see on the attacker account, if we refresh, we now own Cool Harry. Now, as I mentioned, this original bug was found on a site which was giving out license keys, which means that we would be able to steal the license key and actually use the product, right? But if we were buying a real product that was like actually sent to an address or something like that, you may think, well, this is kind of useless then, right? Because, I mean, it's still going to send to their address. It just says that you bought it on your account rather than theirs. It's not a big deal. And partially that's true. But on this website where I found the issue, there was actually a second issue where we were able to steal data. And that is basically that the card details were being stored. So when the victim put in their details, it was also saved to the account that made the request. And since we switched out the JWT tokens, it then applied those saved details to my account rather than to the victim's account. And then from here, whenever you wanted to make a purchase, in the actual application, you would just click on, like, card ending in 3337, and that would be a one-click purchase. Didn't even have to type in the CVV. And so that's basically it. With some perseverance, I was able to change a really boring XSS on a very tiny app with very limited functionality into something way more dangerous, and basically being able to steal people's HTTP request results, essentially. Since obviously we couldn't get the actual request data, but whatever the outcome was, we could take that by forcing our own cookie. And doing this allowed me to change from a medium severity to a high severity, which of course also meant a higher payout and also makes for a way more interesting bug than just finding reflected XSS and doing an alert. So I'll also leave a link to a video by FileDescriptor, as well as some notes that I wrote about that talk, which was basically a talk about cookies in your web browser and the deep dive on exactly how they work. And it was a large help to me in figuring out how to escalate this XSS. So I highly recommend you watch his video.